Sean Cribbs. I've been a long time Rubyist, but this is my first RubyConf, and it was really awesome so far, so way to go, everybody. And today I'm going to talk about resources. For real this time. I'm totally seriously okay, you guys. Everybody ready? Okay, so a little bit of background about me. I work at Basho Technologies. We make this esoterically awesome database called React, and it's built in Erlang. And so while I do mostly Ruby every day, this experience has really informed the talk I'm about to give and all the things I've been thinking about with respect to HTTP. And you're going to hear me say that a lot, so the HTTP bit. So I'm going to start with a little story, and I want to make sure that everyone realizes when I tell this story that I'm not intending to attack anyone specific, but rather make us think about how we do things a little bit differently. So 5 months ago, I posed this question on Twitter, and it ended up on a thread on Convor as well. And I basically said, Rack and WSGI is broken, right? I didn't really say why. I was like, do you think it is? Why do you think it is? Why do you not think it is? And I was really trying to elicit answers like, well, okay, here's how we did something really interesting for HTTP with Rack, or with WSGI, or with Ring, which happens to be the closure port. Or here's how we tried to do this one thing that's very HTTP specific, but our code ended up being brittle and coupled, and it just didn't work right. But instead, I got answers like this. Rack works. Lots of people make it work. So it ain't broke. So I want to take us on a little tour in a very selective fashion of how we've done HTTP programs, HTTP applications with Ruby in the past. So if we flash back to the late 90s, there was this invention of CGI. And CGI was really kind of the first way to build dynamic web applications that weren't actually compiled into the web server. So the way it worked was that the web server would actually fork itself or shell out, set some environment variables, and then exec your program. Those are all system calls, basically. And so your program received information about the requests that came to the web server through the environment variables. It's a really simple way to create an application without a whole lot of needing to abstract or provide an extra API inside the web server. And then if the request included some body, some entity, you would receive that on standard input, and you would send your response back to the web server on standard output. So a really simple model. And so you might do something like this. This is a Ruby CGI program. Notice I didn't even require CGI at the time. But you could just write some headers, writing to standard out, and then write the body. And then that would be passed back to the client. If you wanted to get fancy, you would require CGI. And CGI would actually do some HTML generation stuff like for you. You could tell it like HTML3 or HTML4. How many people did CGI in Ruby? Yeah, okay, quite a few. All right. So this was kind of cool. We had a nice Ruby DSL around CGI. But it's still CGI. So then we got Webrick. And notice these events are not necessarily in any particular order, so take that with a grain of salt. Webrick is cool because it's actually a standalone server. We're not acting as a sub-process of like Apache or some other web server you might have used, IIS, I don't know. So it had this nice little servlet interface, which is kind of maybe influenced by a lot of how Java web application development was done in the late 90s, early aughts, which is you create a class which inherits from a servlet and then provides some methods that will produce a response given a specific HTTP method. So in this case, you send a GET to this servlet, and it's going to set the status to 200 and the body to hello world. This is a really contrived example, but that's basically how you would structure a Webrick application. And then, holy crap, we have Rails. And I put exclamation points on everything like this because Rails was awesome. You guys remember when Rails came out? Ow! Yeah, so holy cow, we have MVC. We don't have to muck with the lower level details. We can make really awesome dynamic web applications. Now Ruby's cool. Okay, so what did Rails look like? You could write a route that would point a specific URL to a controller and an action, and then like down in your controller you could, do some stuff and then render a template automatically. And Rails was really cool because you didn't have to do too much work to get it up and running. And then in 2006, David blew our minds again. We had ZOMG REST. Everybody remember when REST came out? We had this world of resources. We had easy APIs. You could directly map your URLs to your models. It was really awesome. You can actually provide multiple media types with this respond to thing, which is kind of cool. And then you didn't have to create some custom routing to all these crazy actions that you might have created in your controller. You only had to know 7. Only 7. Okay, so that's cool. So in your routes, you'd do something like resources widgets. All right, I don't have to write widgets index, widgets edit. All of those went away. And then you might do something like provide XML to your client if they request it. So in the default would be to render a template. So this is really cool. And amongst all this excitement, I wanted to point out, in a brief digression, 2 voices in the wilderness. And the first one is in 2007, Scott Raymond gave a talk. This is kind of a follow-up to David Hannemeyer Hansen's talk about resources, which is doing REST right. And in this talk, he talked about what Rails said REST was and what actually Roy Fielding's thesis said REST was. And I'm not going to go into the details, but it's really interesting that this talk didn't get more attention later on in the years. And then, and maybe this is just a little bit of shameless brown-nosing to Ben, because he's a nice guy. But in 2008, at RubyConf, Ben Schofield gave this talk, All I Really Need to Know, I Learned by Writing My Own Web Framework. And Ben proposed the idea that actually what we should do is separate the concept of working with collections of things with working on individual items of things, because a collection is a thing as well. So keep these 2 things in mind. If you've seen these presentations before, keep these in mind as I go forward. So then, we started building a lot of Rails applications, and then along came this thing called Sinatra that decided that Rails is too heavy, so let's make it lower level. Let's make it really simple. Let's make a beautiful DSL. It's built on top of Rack. And the way that it worked was that you would have URLs that combined with the HTTP method, and that points to some action that your application should perform. So Sinatra with a little Rack mixed in, this is what the code might look like. We put a middleware on top to say all of my responses are JSON, application JSON content type. And then if I get var, I return some JSON log as the response. So I want to take a deeper look at Rack. And here's probably where I'm going to make some people mad, so beware. Rack is structured in an interesting way. At the top layer, facing your client, facing your web server, are these handlers and your web server thing. And what that does is it takes the web server handles the bare HTTP transport and understanding the messages and parsing it and producing messages on the way out. And they have various handlers. You can plug all kinds of different web servers into Rack. And it's partly why we have so many Ruby web servers, is because Rack provides this very consistent interface. And then you would have a stack of middleware. And middleware do various things along the way to change the input to your actual application or modify things that are in the response on the way out. And then at the very bottom of this stack, you have your actual application. So Rack has a really simple interface. And it's when you want to make a request to an application, Rack does app.call and passes this hash called the env. And then all the contract of your application is to return an array, of 3 elements that includes the status, which is an integer, headers, which is a hash of response headers, and then the body, which is some kind of enumerable thing that can be written out in the response. So it's a really simple interface. It's simple to understand, and it promises a lot of things. One of the things that it promises is composability. Because you've isolated these things into different strata, you build middleware to wrap new kinds of behavior around your application. And again, it has a simple interface. This is really, really beautiful to write things in a really compact form, and you always know what to do to invoke the application. You always know that you're going to receive an environment hash. And there's the potential there for the separation of concerns. And I'm actually going to challenge all of these things in a moment. But, so let's take a look at Rack's primary mantra is, if you like this thing, put a middleware on it, right? Okay, so you want this behavior, write a middleware. And this might be some middleware we wrote, and it calls in and it adds a header to the response on the way out. So that's pretty cool, right? So put that back up there. That's great. I was looking for an opportunity to use that in the presentation. Okay, so I want to actually look at why, at my original premise, which is the unasserted assertion, the unsubstantiated assertion I made back in May that Rack is broken. And I want to talk about individual problems that I started to run into when I was building lightweight web services for automation of the work that I do at Basho, and various other things that I wanted to make my life easier. So I think the biggest problem with Rack is that when you build a middleware stack, and you've got your application at the bottom, and you've got this stack of middleware, the only tool that you have is the environment hash going down the stack, and the 3 tuple essentially going back up the stack. Your application does not know what comes above it, and your middleware doesn't know what comes below it. And so you have a bunch of problems when you are trying to do interesting HTTP behavior. And what this results in is actually the environment hash becomes a dumpster. So the environment hash actually comes from the idea of environment variables in CGI. This is not a new idea. This is not a revolutionary idea. But with the environment, if that's the only thing you have that you can pass down the stack, you'll throw everything in it that your application down below needs. And so it becomes this kind of ugly ball of mud that flows through your application. And your applications down below don't necessarily know what's coming in it. It's not just information about the request. It's also like, hey, what do I log to? What's my session store? Those kinds of things are actually tangential to the concern of how HTTP works. Rather, or probably orthogonal is probably the better word for that. The other thing is that in this dumpster of the env, you tend to communicate by convention. Your app starts to realize, oh yeah, I have this rack.logger key that I can get the logger and log some messages to the console. Or I have this rack.session or rack.input, which I can read the input from. And it's not actually saying, your middleware stack and Rack is not actually passing these things explicitly to you in a form that you can understand unless you know what's in that environment hash. The other aspect is middleware order matters. So a good example is the HTTP spec says, let's say you want to use content encoding of gzip, because you want to make your responses smaller. However, the spec says that the length of that response the content length header needs to match the actual length of the response. So if you, by mistake, put the content length middleware that you've created to figure out what the length of your response body is, if you put that below the gzip, you're breaking the spec. And your client's probably going to go, this thing's corrupted. I don't know what to do with it. So middleware order is really significant, probably more significant than it should be. And the other issue is because we have this, the environment is a dumpster, it's blind up, blind down, you end up not separating concerns the way you intended to. You end up actually introducing coupling between components in your application because you can't separate what the middleware does to the environment from what your application is trying to do with that. So you introduce a lot of coupling. So that's enough about that. I've bashed it enough. I want to make this better. So what can we do to make RAC and building HTTP applications on Ruby better? This is a big graph. You're not supposed to be able to read it, but I think the first thing we can do is realize that HTTP is hard. This is a flowchart that was developed by a few people who I know, and they went through the RFC for HTTP 1.1 and said, here are all these assertions, these musts, these shoulds, these should nots, these mays that happen in the spec. And let's turn that into a logical model of, given these constraints, what response code should the server return? I don't know about you, but if you look at this flowchart, it doesn't look like a composable stack of things. It branches. It actually doesn't look like a stack at all. It looks like a state machine. It has various transitions and various end states, and a start state with the black dot there on the left. So we have a lot of hard questions to answer. Is this request method given by the client allowed? What kind of media types does my application provide? What should it return given this client request? Is the response cacheable? Did they send a conditional request? How can I determine whether the response should be a 3 or 4 not modified or not? Did the resource move? Is this a redirect? All of these questions are really hard to answer with RAC because the question becomes, where do you put this logic? Can your middleware answer these questions? Can your application answer these questions? And usually I found when putting these RAC applications together, I was pushed in either direction. I either put most of my things in the application, which means that I have a lot of this logic that I'm rewriting every time, or I pushed it in the middleware and I've introduced coupling down the stack. So I think what we can realize from this, and especially that flowchart, even without understanding what's on it, is that the HTTP RFC has been around for a good 10 years or so. HTTP doesn't change. What changes is our applications, the resources in your applications. So what we can do is we can encapsulate those hard decisions and then reuse them for every application. There's no reason why your application has to pick and choose which behaviors of HTTP it wants to use. That logic is separate from what your application actually is. So let's think about shaping our applications like HTTP. Let's use resources. What does the spec say a resource is? And this is paraphrased. You can find this if you go to the IATF's site. Sorry, just a quick digression. Don't ever try to argue with someone about RFC 2616 because it will go on forever. And here I am starting this argument, so feel free to hit me up later. A resource is essentially a data object, like a file, or some piece of bytes, or some service that is being provided to a client. Resources are identified by URIs. So there's this dual between a resource, its data, its the service that it provides, and what its URI is. And so these are the two most important concepts with respect to understanding resources. And then there's also the idea of representations. A resource may have some multiple internal representations, multiple representations it exposes to the client. And when I say representations, I mean things like the media type, the content type, things like the encoding. Is it gzip? Is it deflate? Is it just bare? And also things like the language. Lots of people want to do multilingual applications. Representations allow you to do that. And then there are other variances in properties which determine the behavior of a resource when a request is made. So I want to introduce Webmachine to you guys and how it helps us do HTTP better. So what is Webmachine? Webmachine is a toolkit for easily creating well-behaved HTTP applications. And I broke those out so I could address those points individually. Webmachine is not a framework, it's a toolkit. All it does is encapsulate HTTP behavior and expose it to you in a way that is just leaky enough to get your work done. It is for easily creating these applications because it encodes a lot of defaults, sensible defaults, about what you want to do in your application without you having to write a huge configuration file or a lot of code. And when I say well-behaved, what I mean is these are your resources that you create with Webmachine address all of the constraints in that spec very carefully. And the logic of addressing those constraints of the HTTP spec is separate from what your resources are. And they're HTTP applications. And this is a little bit more subtle, but you don't use Webmachine or any of the aspects of Webmachine to write a WebSocket server. We're talking about applications that are specifically focused on the request-response cycle of HTTP. Another way to think about it is Webmachine is an executable model of HTTP. Do you remember this graph I showed a minute ago? This graph actually is code in Webmachine. Each of those little diamonds on the flowchart is a single state of a finite state machine. Each of the boxes is a response code that Webmachine will return when a given branch points to that end state. So this is all wrapped up in code. The spec is executable in that sense. So Webmachine is shaped like HTTP, which means that instead of defining what action your application should take, it has you declare resources. So it's a lot more declarative than imperative. And then because it encapsulates all of those constraints of the HTTP spec, it will negotiate those hard decisions that we talked about before transparently. And then it will respond with the right status code. And of course, it uses sensible default behaviors so that you don't have to write everything, every little decision that your resource exposes, every little property, you don't have to write it up front. There's a lot of sensible defaults. And I can't emphasize this enough. Webmachine is not a framework. It has no ORM. It has no templating system. You can hook one in if you want. It has no plugins. It has no asset pipeline. I knew that one would get some response. So it's just a resource server for writing web applications. I might gloss over this a little bit. It's resource focused, so this means that resources are the core building block of the application. Resources are grouped by common behavior into classes, which I tend to call resource families. And those are subclassed from the Webmachine resource class. And these resources have a well-defined, consistent interface to the HTTP logic that is encapsulated in that state machine. And then you take a step out of your resource and you actually map your URIs, patterns of URIs, to those resource families that you want to provide. So again, the code is a little small, but there are 36 resource callbacks that you can define. And I'll show in a minute, with some code that you really only have to define one if you just want to produce an HTML response with 200 OK. But you can do a lot of stuff, like you can provide different representations. You can provide different languages. You can tell when the resource was last modified. These are all kind of declarative properties of your resource. There are a few of these callbacks that are actually here, take an action. But those are very constrained and limited in number. So it has a very simple dispatching. It doesn't use any rack routing or anything like that. I didn't even copy any code. But basically, it'll take the path of the URI, break it into segments, and then if you put in your segment, in your route pattern, symbols in the pattern, it'll bind those segments of the path to symbols. So this is similar to what you did in Rails, where you did like slash and you colon something, you slash colon something else. You can bind path segments to symbols. You can also have a trailing wildcard on your route, which will match any number of segments in the URL. So this is kind of like the splat URL you might have done in Rails as well. And those will be available as an array of segments to your resource. And then there's also, in addition to binding portions of the path to a symbol, you can also bind arbitrary data to a symbol. So that will be injected into this path binding information when your resource receives a request. And this is not entirely clear from this slide. We'll see a bit more of this later. So I really want to get into an example. You know, I've talked about the high-level stuff. I've talked about the model. Let's actually do something for real. And I'm going to attempt the presentation guides by doing a live demo. So let's start by first creating a very basic resource. You just require Webmachine, and you define a class which inherits from Webmachine resource. And the only callback, the initial callback that you have to provide to produce a 200 OK with HTML is just this toHTML method. And all it does is return a string, which is the body. That's pretty simple, right? I said easily creating, right? Okay, that's not too bad. Now that we've got a resource, let's hook it up and actually add a route. So I'm adding a route to the dispatcher, which, and this API will probably change in a next release, probably. But I'm basically just saying at the root URL, there's no path segments, just the root. I want to map that to the page resource, and then I'm going to run the server. So here's where I attempt the demo guides. Switch to terminal. Okay, so I've created a bunch of these examples actually in Ruby files, and we're going to run them individually. Oh, I broke it. I'm sorry. I did attempt the demo guides. Okay, let's try it again. There we go. So it spun up Webrick. There are actually two web server adapters available right now for Webmachine. The first one I wrote is Webrick because it's really easy to understand and get hooked up. We also have Mongrel 1.2 pre-whatever, and I'm working on more as we go. So we've got this web server running. Let's flip back over to our browser. Let's see if I can't get it up. And let's go to, there's my mouse. Let's do localhost port 8080. And there, okay, so this is not really revolutionary, but there's some content that we produced. Okay, that's not really that interesting. All right, content. Who likes content? Okay.
You're ready for VC?
Yeah. All right, man. Start my startup now. Okay, so we want to do more than just send a static string to the browser every time. So let's add an ERB layout and render some stuff in this template. So we made a really simple ERB template, and it kind of refers to this page thing. So we're talking about a page resource. Maybe in my application, I'm going to put a page model in there somewhere. And then it'll have a title and content, and I'll just put that in H1 and be done with it. So here's the interesting part. We're going to start implementing some more callbacks. And I've created the page model for now as a little struct that has a title and content. And then I'm going to implement this resource exists callback. Now, it's not really that interesting in this example, but we'll see how it becomes more interesting in a minute. So we just created a new page object from that page struct, really, and we say, yes, this resource exists, so I'm going to return true. If I return false, do you get a 404? It's pretty clear. Okay, and then I've changed my toHTML method to take that ERB layout that template that I did, and evaluate it against the binding of the local object, which has the page as this variable. So let's switch back to my terminal briefly. Okay, so I'm going to kill this example. Control C. And we're going to run example 2, which has our layout. Okay, and let's refresh that. Okay, now I have an H1 and it says hello world. Okay, that's not very exciting, but let's add some more interesting behavior to it. So we could actually use a real model for that, and I create this sort of ORM document mapper thing for React. It's called Ripple, and it kind of looks a little bit like Data Mapper, a little bit like Mongo Mapper. So we make a real model that reads something out of a data store, and it has title, content, and it has updated out, created out timestamps on it. That's no big deal. So here's where that resource exists gets interesting. Let's see if we can't find that model to be rendered in our resource. And then if we don't find it, we can say, if the page.find call returns nil, so there's no object there, then we can say, well, is the page present? And if it's not there, you can return a 404. Oops. So in order to support this, we need to add a route. And notice I mentioned the path bindings. That's part of the request object that you have available on your resource. And it's just a hash of all the bindings that the router created for your resource when it matched the path. And so in this case, I'm using a simple path segment that's a slug. And remember I said you can have static bindings on your routes. So in the case of the root route, we want to say, well, the slug is some magic name. This is not really interesting in CMS, sorry. So we always have a binding for that slug in the path information that we can use to try to find the model that we want to present to the client. Okay, let's go back to our terminal and run that one. Sample 3. Yeah, it's complaining about warnings. Running active model 3.1 and my Ripple's not up to date. So if we switch back to here and we refresh, and hey, before this presentation I put a root page in there. So we have another page. And actually if we go up here and put in some other URL like foo, okay, we got 404 not found because it didn't find that document in the React database when it tried to request it. We haven't written much code yet, have we? Okay, so we're still on the front. Okay, let's go another step. We want cool APIs. So let's implement JSON as a media type. Okay, well this is pretty simple. Actually, all you do is you implement the content types provided callback. And this is actually one that was a default. And the default was that first array in the nested array, which was, I want to return text HTML and call the toHTML method to produce a body. So we want to provide application JSON media type and call toJSON to produce the body. And all we have to do in that toJSON method is take the page object that we've got already and get its attributes and call it toJSON. So this one I'm going to have to do in the terminal, so I'm going to flip over here. First, let's fire up our next example. And then I'll flip over here. Okay, so the interesting thing about Webmachine is it doesn't actually use portions of the URL to tell you what media type to return. That's actually, in some ways, an anti-pattern and but a workaround for browsers so you can see your JSON or XML, right? So actually, the proper way to do it with HTTP is to send an accept header. Say, I want this media type, or I want these possible media types. So without going into too much detail about it, I'm going to use curl and set an accept header of application JSON saying, I don't want the HTML format, I want the JSON format. And request it, and hey, I got JSON back instead of HTML. That was pretty easy. Look, it even said, hey, you can vary what you get back by changing your accept header. Okay, so let's add conditional requests. This is pretty simple too. Remember we have those timestamps to our model. We can say, oh, the last modified is last time that the model was updated. And then incidental to the implementation of Ripple is that there's actually an object underneath the model that has some properties that were received from the React database, including an e tag. So we can just kind of reuse that e tag as the e tag for our resource. So if we flip back here and run the next example. Okay, and let's go back to our browser this time. And in order to get this to make sense, I'm going to have to pop up the web inspector and go to the network tab. So if I go back to the root URL, which I knew had a page before, you see we have a 200 response down here. What if I navigate to it again? Oh, Chrome cached it. I got a 304 not modified. How easy was that? How many times have you tried to do, tried to do expires or fresh or any of that stuff in Rails? Remember how hard it is? I think this is lots easier. Okay. Enough straw man. Let's get back to the other one. Okay, so we need conditional requests. Now we actually want to make kind of a CMSy-like thing, so let's receive representations as well as producing them. So we have to actually add a couple more callbacks here. One of them is the allow methods. So if I before had sent a request to this resource and said, here, I'm going to put a representation, it would have said, sorry, that method's not allowed, because the default is like get head options. So let's add put as a valid method. And then you can specify what content types do you accept. So you can actually say, I don't want to accept HTML. I want this kind of fine-grained JSON thing. So if somebody posted HTML or like a web form, it's going to say 415 media type not recognized or something like that. Sorry, I don't remember the exact one. But so again, like the content types provided, we send a callback, which is store page. We say, when you receive this content type, run this method. And in this case, when we receive a page representation as JSON in a request, we don't know necessarily whether that resource existed before. So maybe we looked it up, maybe we looked it up in the database, but it wasn't there, and we normally would have returned a 404 not found. It's actually okay to send a put request to a resource that doesn't exist. You're telling it, here's a representation of something new. So in this case, we're going to take the slug out of the path info that we bound earlier, remember, and set it as the key of the primary key of this object. And then we'll parse the body, response body, as JSON and run update attributes. That's pretty simple. So let's run that example. Example 6. And again here, because I'm only putting JSON, I have to do this with curl, so bear with me on that. So here's what we're going to do with curl, and let me fix that too. So we're going to say content type of what I'm posting is application JSON. I'm going to receive the data on standard in. That's what the @ means. We're posting it to the root URL, so we're going to change the home page. And then we're going to use the put method. And here I'm going to paste in my response or my request body and send it. And it said, okay, 204 no content. which basically means I received the put. Nothing went wrong. So let's actually see what happened in our browser. Let's refresh that. Oh, hey, I changed the home page. That's pretty cool. But, you know, you're building a web application, you kind of want to secure the edges of it. So maybe you want to authenticate puts. So let's add basic authentication to this. Now this code is a little bit more squirrely than what I've shown before. That's probably because I didn't encapsulate this basic authentication into something else. And I actually have intentions to do that in the next release of Webmachine. But basically what we're doing is just defining another callback. Is this request authorized? And what that callback gets passed is the header, the authorization header or authentication header. And so in this case, if the method is put, if it's not put, yes, it's authorized, go ahead. If it is put, let's check what the authorization they gave me was. And the stuff down at the bottom is really just, let's decode the base 64 and split the username and password and make sure that it's this credentials. I could have done this more elegantly, but I figured it was a pretty simple example. So let's actually see what happens when we authenticate our puts. This is my final example. Okay. So if I try this one again, and I post that, I get 401 unauthorized. And it says, hey, you need to authenticate using HTTP basic. You look at authenticate, www authenticate header. That's where you see that. And now, actually, why don't I go ahead and put in there the username and password, which is another little curl flag, and try the post again, or the put rather. It says, okay, cool, 2 of 4 no content. I actually updated it again. Let's run this again and and change this a little bit. Website. Okay, so it accepted it. We go back to the browser, refresh it, website. So this is not really revolutionary stuff, but I hope what you see is that, get back to the right browser. I hope what you see is that you've actually started thinking about your application in terms of how HTTP sees it, rather than in terms of it being like MVC or this wrapped middleware stack that doesn't know anything about HTTP. You're constructing your application in the shape of HTTP. So you can get Webmachine on GitHub. It's also available as a Ruby gem. My slides are in that second link. That's the actual repository for it, where you can go Heroku.com. This is the show off, and review the slides there. I do want to give a few acknowledgments. My coworkers and some really awesome people, Justin Sheehy, Brian Fink, and Andy Gross, who created the original Webmachine. I'm not that creative or smart. They figured out that flowchart, and they encoded it first. It was in Erlang. So if you want to see the original source and how much the Ruby part, or the Ruby counterpart deviates from it, go there. And then I have a couple committers who've helped me move it along in the past month or two. Ian Klosker is a coworker of mine, and Barry Dollars, who's just some guy who kind of thinks Webmachine is cool. So I would be happy to take questions. I know I was going to run long, but you know, in any format but these languages. Anybody? Yeah, in the back.
I can see how it's a really nice abstraction around HTTP, but do you see there being an advantage to doing something like a layer on top of like Sinatra? Because Sinatra's fairly pretty, or does that defeat the purpose of this very HTTP language?
So I think the question was, do you see a layer going on top of Webmachine that is more abstract, more friendly? My contention is actually this is really simple, and I'll show you if I have the example up. I'll show you the final version of this application that we just built. I guess my point is that when we do something like Sinatra, you're focusing on the action the server should perform, not what the resource is. And HTTP, except in a few very narrow cases like a post request, is not about performing an action. It's about transferring representations in an essentially stateless protocol. So the other thing about focusing on an application as actions rather than a resource is that you're encouraged to introduce side effects where the protocol says this should be side effect free. And so I'm not saying that Webmachine will replace anything we already have, because obviously, as people said in that first question that I posed, it works. It works for a lot of people, and I don't expect this to replace Rails or Sinatra or any of those things. But what I would like this to do is actually get us thinking about how can we do HTTP better, and how might we evolve the other things that we like to use from day to day. And is there a question still over here, and then I'll continue. Constantine?
Yeah. First of all, a few things to that. There are plans there are at least 3 core team members of Rack here, and we had a meeting, and there are plans to write a replacement for Rack and have future Rails and Sinatra versions run on top of that, but it still will not be declarative. And I totally agree with most of what you said.
See, I saw you in the front row. I was like, I'm probably gonna piss him off.
No, actually, I had some of my thoughts are similar to that with the resource oriented and so on. Talk to people about that. There are a few things though. First of all, a comment on. No, I'm not sure how much I should go into detail. I should do that in person. But how do you deal with how do you deal with, for instance, web browsers treating HTTP like crap?
So in this case, I would say the question was, how do you deal with bad browsers treating HTTP like crap? And I think that this is a real problem we as developers should start addressing. We need to start.
You could not use that CMS with the browser because most WebKit browsers and Internet Explorer do not do proper content negotiation.
I agree. They do not do proper content negotiation. And my point is that what we should be doing is providing pressure against browser. I mean, how many times have we had that extra query string thing to override the method? How many years have we had that? It's been a long time. I think we should be putting pressure against browser implementers to say your HTML form should be able to have a put method. And I understand the accept thing, and I don't think that is going to change anytime soon. But I think the times that you want to provide different formats to a browser, you're not going to be doing an API type thing. So, I mentioned that I don't think that Webmachine is going to replace, or its model is going to replace Rack or Rails or Sinatra. And part of that is that Rails especially encodes a lot of information about how to deal with bad browsers.
Yeah. Also, another question is, are you planning on implementing the complete HTTP spec?
So that's a very loaded question. So the question was, are you planning on implementing the entire HTTP spec?
Like, for instance, you're not dealing correctly with optimistic locking with the if-modified synth headers at the moment because you have no notion of a resource being existent or not.
That is actually incorrect. What the flowchart does is if the resource does not exist, then you never enter conditional requests negotiation. So because there's no way, so it will actually see if you pass an if match, if match or if none match star, you will actually get a 412 precondition failed response.
Okay.
if the resource does not exist.
Okay.
So
The context is you could do an HTTP request basically saying only update this page if it already exists, or only
Right.
create this page if it doesn't exist, and there is some
So
tricky logic in there.
there are ways we can improve that for sure. And in fact, it's been a couple years since that flowchart was designed. And I know there are some additions that Justin and my other colleagues will want to do. And I'll be sure to encode that in the Ruby version as soon as I can. Okay, we're way over, but one last question.
Well, I'm sorry, my question was very similar. I just said, do you make any allowances for the fact that browsers can't submit anything other than get and post?
Yeah, so the interesting thing is we actually, in the Erlang version, resources we've written, we will actually allow post for clients that don't understand put, and then kind of through a little bit of inspecting the request closely, kind of upcycle it to a put. So there are ways to do that. They're not the pretty declarative way. You have to look at it a little bit more closely. So anyway,
Reality.
yeah, reality sucks. This is an ideal. Thank you so much for listening to me.